Hi guys, let's do backspace string compare. So we're given two strings s and t, and they want us to return true if they're equal when both are typed into empty text editors, and the pound character means a backspace character. They say, notice that after backspacing an empty text, the text will continue empty. So in example 1, we're given input string s is this and input string t is this, and we output true because once we backspace the character, like we remove the pound and the character before it, after we backspace it for each of these, they both become a C. So they're equal. In example 2, we're given input string s is this and input string t is this, and we output true because after we backspace, they both become an empty string. So they're equal. And in example 3, we return false because after we backspace, the first string s just becomes C, while the second string t becomes B, so they're not equal. So to do this one, we can loop through each string and add each character onto a stack. So if we have this, then we'll have two separate stacks, one for s and one for t. So the stack for s it starts out empty, and same with the one for t. And then as we iterate through s, we get, so we have 4 characters and 4 characters. So when we're looping through s at 0, we encounter a, so we add, and since we don't have anything in our stack yet, we're going to just add that. And then at index 1, we encounter b, and so we add that to our stack. And then when we get to the character at index 2, it's the pound sign, which is backspace. So because we're backspacing, then we can essentially just remove this b from our stack and then keep going. So at index 3, we have a c, so we add c to our stack. So basically, we just want to add everything to our stack unless it's a pound sign, and then we just remove 1 from our stack. Unless it's empty, then we just do nothing. And by it, I mean our stack is empty. So, and then for t, we can loop through. At index 0, we have a, so let's add a. At index 1, we have d, so we'll add d. Then at index 2, we have a pound sign, so we'll delete the most recent character, which is d. Then at index 3, we have a c, so we'll add c. And then at the end, we just want to check if these two stacks are equal to each other, and they are, so we can return true. Okay, so because we're doing a lot of repeated work here, we have 2 different stacks, 2 different loops, both looping through the strings. I'll just create a private method to do all of this work. And so we'll just return the stack at the end, because then we can just check if they're equal. So we'll have 2 stacks of characters, and we'll name this build stack, and we'll take an input string, and I'll just call that stir. So we will need to initialize our stack, and then we'll loop through our input string. So then we'll just assign a character C to the character at that index. And then we're going to check if it's a pound sign. So if C is a pound sign, then if our stack is empty, we do nothing, because when we delete and there's nothing, it's still nothing. And if it's not empty, then we will pop the top character off of our stack. So we'll just say stack.pop, and that will just remove the most recent character in our stack. So there's no else because we do nothing if it's empty. And then else for here, so if it's not a pound sign, that means it's a letter. And if it's a letter, then we will add that to our stack. So we'll just say stack.pushC. And then at the end, we'll do this for every single character in our string. And then at the very end, when we've reached the end of the string, we'll just return this stack. And then up here, we will just want to compare if we build, so actually return. And we're just going to return if the stacks of each of these strings are the same. So we'll say build stack for s dot equals build stack for t. And that's it. So, okay. And then our time complexity, what we can say is, so, okay, let's think back to our algorithm again, actually. So we're looping through each of these strings once. So we're visiting every character in each of these strings, which we can say is s plus t, where s is the number of characters in our string s and t is the number of characters in our string t. So far we have s plus t, and we can see that in our loop down here, which we repeat for each string because we call this method for s once and we call it for t once. So we have just O of s plus t, that's it, because that's our only loop. And then we can say s is number of characters in s, t is number of characters in t. Okay, and then our space complexity, if we think about our algorithm here, we have a stack for storing all of the characters in s, and we have another stack for storing all of the characters in t. So our space complexity is also O of s plus t. And that's the same thing. So, and we also, because we call that method twice, one for each string. So that's it for this problem. Thank you guys for watching. Bye.